Welcome back to our Spark learning session. Today, I'll be going through the practice of logistic regression code along exercise. So, for starting, let me import some PySpark session and also require libraries for this exercise. And I only imported the required libraries here for our exercise such that I don't have to import it again. Now, let's load the Titanic data set for our exercise. Spark equal to spark session dot builder dot app name Titanic dot getter create. This is one thing. Second thing is input data. Now we have loaded a Spark session. Now next job is to load the input data. We have started the Spark session here. Now let's load the input data. Input data equal to spark read dot csv, and the file we want to read is titanic.csv. Titanic.csv. Infer schema true, header equal to true. At this point, let me briefly go over the project overview. What we are trying to do is we have a data set of Titanic where we have a features associated with the different passengers and whether each passenger survived or did not survive. What we'll do is we'll use a set of data to train our logistic model to predict whether a passenger would survive or not survive based upon their features. And we'll use test data to the prediction and where how accurately our model can predict whether a passenger will survive or no based upon the features. That's our scope. Now let's see what we have in the input schema, input data. Let's run this first. 1, 2, 3. Running this. And let's try to see what's inside the input data schema we have. How many columns does it have? What's the data types? We need to understand that before we do anything with data. And let's do it. It is running currently. Not sure how long it's going to take to run this. Now let's keep typing the other commands that we need, even though we don't run it right away. Now we need to select the certain features that we are interested in. There will be feature select equal to input data. We'll use certain features to select. For our machine learning model, let's do that. We want feature survived. We want feature passenger class. Titanic. Let's get this correctly. Titanic. Let me run it again. Passenger class, and we are interested in sex of the passenger. Survived passenger class. We are interested in sex of a passenger. We are interested in age of passenger. We are interested in siblings, spouse, parchment, fare, and embarked. Let's run this and what it has, what columns it has. It has passenger ID, which is integer, and survived 0 based upon whether passenger survived or no, based upon this is actually the fact. It's not a prediction, but it is a fact. Whether passenger survived or not, PC, passenger class, and all other attributes of the passenger. And we'll do select a features that we are interested in. Next, let's drop this data set do not have 100% completeness, so we'll be doing some kind of data cleansing by dropping all the data that has not null values, and that's what we do here. We'll dropping all the null values from the data. Now this data has some columns which are of course categorical. Let's try to see what this kind of what data this has and try to describe it. Let's see what kind of data does it have. This data must have some category columns. Describe and show. We want to see what the data has. Survive. This is a sexy category column, and embarked is a category column. What we need to do is we need to turn them into a non-category column, or you need to properly process this category column so that they can be used in our model. For that, we'll use string indexer to process this category column. Starting with gender, we'll call string indexer method that would take the that would take the input column as sex, and what does it do? It once it takes input column sex, it does some processing and produces output column called sex index. And when this is done, then it would use encoder to encode using one hot encoder to create a one hot encoder array for each of the sex, gender, and a one hot encoder. And why do we use one hot encoder? Why don't we just use string indexer? Using one hot encoder has definitely advantage because it is impartial. We are just using 0 and 1, and it is more impartial than the string indexer. Let's say there are three sexes, male, female, and the other sex, and using 1, 2, 3. When you do that, it can produce some kind of bias between 1, 2, and 3. But when we use gender encoder, we'll use as a one hot encoder to for each gender. There would be, let's say that person is male, then it's going to be 1, 0, 0. and let's say it's a female 1010. In that way, it is more impartial, and that's why we use one-hot encoder than just indexing the string. Well, let's use one-hot encoder, and input column will be string index. Input column will be string index, and output column will be sex vector. This is our gender encoder. We need to assign this string index into string indexer, and then do gender encoder. These are two different functions. We need to assign these into the labels because we need to call them separately. That's why we are assigning them into a different variables or pointers. Secondly, we'll be doing similarly with the gender, we'll be doing for embarked. Let me replace gender with a embarked here. Replace find gender and replace with embark. Let's see what we get here. Replace embark, and let's replace sex with embarked variable. Now let's run this again. Let's see what we get. Now we have these two category column that are indexed and encoded. We need to create an assembler that assembles a vector or an array that will be used for our model. Assembler assembles a vector array that will be used in our model, so it's called vector assembler. And ingredients that it needs to assemble a vector or array is vector input columns equal to there are certain input columns it needs. What are those? I'll give you those here. These are the input columns it needs, and in terms of sex, it would be using sex vector. And in terms of embark, it will be using embark vec. And output column features. So we have our assembly ready. Now we need to build a pipeline. Pipeline not those. That's what exactly means. It is a pipeline. That means it is a sequence of activities that we put together such that we get result that we want. Starting with the input data, and we transform data in several steps, and we get output data. There is a pipeline. And the beauty of pipeline is that whole pipeline can be used as a model, data model, instead of like a only certain piece of the pipeline. The whole pipeline can act as a single model. That's the beauty of that, and it makes a lot easier to work with the pipeline. Let's build a pipeline here, working with logistic regression model. label column, survived. What do I do here? What do I do here? I create a logistic regression model with a label column that I'm using as a guide called survive, and I'm creating a logic regression model here using that. Secondly, it also takes another column called in features column called features from this assembler. This feature columns will be used by logistic regression model to input as a source to train it. Next will be a pipeline that what we have been doing since past few minutes. This is the whole main meat of this code, building the pipeline. First step, and there are different stages in a pipeline, and let's name them so that it is clear for everybody. So first step is to do the indexer. Second step, we'll do encode it. Third step, we'll take the embark indexer. We'll do the embark indexing, and then we'll do embark encoding. Okay. Next step, we'll assemble our vector that we need for learning model, and then we'll train the model on the features from the assembler. These are steps that we will do in a pipeline. Now we need to train the pipeline or train the we train the pipeline on the training data. Therefore, we need to separate the training data from we need to create a train and test data from our data set. For that, we'll do random split. That would be 70-30%. 70, 30%. 70% would be train data, and test data will be 30%. What is our next step? What do you think we should do next? Next step, we need to train our model. The model we have created here, we need to train it based upon the training data. How do you do that? Let me show you. Let's use the pipeline which acts as a model itself, and then fit the model on train data. And whatever new model we get, the trained model will be called fitted model. Fitted logarithm model, that's what it will be called. We run this. Now we have our model. Next step is to use this model on the test data to get our predictions. Predictions labels we'll name the labels for our new predictions that we get on the test data. And let's use this fitted regression model on the test data by using transform, and the input we have for testing is test data. The result will be stored in prediction labels. This is all good. What we should do now? Now let's look at the prediction labels. What's inside it? Let's see what do we have here? Let's see the fruit of results. We have the prediction labels, and since it is perfectly predicting based upon the data what we have. This is a survived, this is all prediction. It's perfect, it's almost perfect. Let's evaluate our testing result by doing B binary evaluators. Using a binary evaluator, it is called B eval, and it uses a method called return receiving operating curve. And let's use binary classification, and label column that we'll be comparing against is prediction versus label column is survived. That's what we'll be comparing against. Receiving operating curve ROC result will be the result that we are looking for, and let's name it as such, and let's use a evaluator. Let's do the evaluator to get some results here. Dot evaluate, we use evaluator to evaluate the prediction labels, which is the result of our evaluation, which is the result of the running a fitted model on test data. Now we have a ROC result. It's almost perfect. So this is our Titanic logistic regression code along. In the end, let me quickly summarize what we learned today. We learned about using logistic regression on Titanic dataset. Here, we use different functions such as vector assembler, one-hot encoder, string indexer, pipeline, binary classification evaluator, logistic regression to do our exercise. We started with inputting the data. We did some data analysis and cleansed the data. Then we separated a select set of features that we are interested in. Then we look at some category columns and we encoded them in using indexer and one-hot encoder. Then we build a pipeline for all the activities we need to do, starting from encoding to the building the data model. Then we use the pipeline to fit on the test on the training data, and we evaluate our result, evaluate our model on test data, and then we evaluate the result of evaluation on test data using a binary evaluator, and the result we got was a perfect one. That's all for today. I will see you next learning session. Thank you so much.